start it. Hi, fourth grade. Happy Fun Friday. Today's Hat Day. So today's our last review lesson of our fourth grade math material, which is exciting. So I'm just going to go through these problems relatively quickly because it is a review, but if you need any further help on any of the problems, pay close attention to these sections that they give us in blue. And go back and rewatch those videos to kind of learn what we learned about and to help you review. So looking at lines of symmetry. So one thing that we talked about on our Zoom call is that we want to pay close attention to the angle measures that are given. So for 16, these are all equal sides. We measured them and decided that they were all the same side length. So there are 3 lines of symmetry. Ooh. 1, 2, and 3. So just paying close attention to that. Those are all equal side lengths and the angle measures are equal. But when we look at 17, we notice that we have an obtuse angle here and an acute angle here. So there's only 2 lines of symmetry and they're going to go vertically and horizontally. So one vertically this way down the middle. And it's not perfect, but that works. And then one horizontally across the middle there. We cannot cut it here because, again, these angle measures are different. So if you want to prove it, what I would recommend is that you take a sticky note or a piece of paper and trace that shape, cut it out, and then fold it and see if you can find any other lines of symmetry. You shouldn't be able to, but if you do, let me know. All right, 18, 19, 20, and 21, we're using this map. So we're paying close attention to the street names that they give us and recognizing that the different streets have different angle measures when they have cross streets, and some of them don't touch at all. So the 18 says, Suli and Tai are walking along parallel streets. Which 2 streets in the map appear to be parallel? So remember, parallel, just like those L's in the word parallel, the lines don't touch. They never touch. They stay the same distance apart the whole time that they continue forever and ever. So if we look at Arrow and Carmichael, these 2 streets, they don't touch and they never will. So Arrow Street and Carmichael Street are 2 parallel streets. Number 19 says, Cross Street, West Street, and Carmichael Street form a triangle around a park. Classify the triangle formed by the streets by its sides and its angles. So we're talking about this triangle right here. Now, when we see the side lengths, we want to measure them to see if there are any equal side lengths. And if you measure closely, you'll find that these 2 streets, or these 2 sides of the triangle, are equal triangles, or equal side lengths. So when we have 2 sides that are the same, we call it an isosceles triangle. And then now to classify by its angles, we have an acute angle, and a right angle. One right angle in a triangle makes a right triangle. Number 20, what is the measure of the obtuse angle formed by Pleasant Street and Carmichael Street? So there are 2 different ways that you can do this, and I want you to be able to do it both ways. Now I can't on my iPad use my protractor and show you, so I'm going to show you the math way, and then I want you to check my work with your protractor. So we want to know what this angle is. And we know that Pleasant Street, when we have a straight angle equals 180 degrees. And we have 2 parts of the whole of 180 degrees. We have 30 degrees and 45 degrees. So we're going to take 180, because that's our total, we're going to subtract it from 30 plus 45, because that's our part, that's this angle that makes up the other part of the whole that we know. So then we do equals x, x equals, and when you do all your math and you double check everything and you've used your protractor, you should get an angle measure of 105 degrees. Then we want to double check, because we know that this is an obtuse angle and 105 degrees is an obtuse angle measure. So just double checking and using what we know and what we know obtuse angles or acute angles look like, and then using the angle measure that we get to double check our work. Now, 21 says, which two streets are perpendicular? Remember, to be perpendicular, you must touch and you must create right angles. Now, there are two sets of perpendicular streets here. One is given to us right away. Let me clean this up for you. One is given to us right away with this right angle symbol. So we have Carmichael Street and West Street. And West. And we also have, since Arrow and Carmichael Street are parallel lines, West still creates a perpendicular line with Arrow. So this should be a right angle as well. So that's West and Arrow. So just keeping that in mind, that we have one that they tell us right away with West and Carmichael, and then one that we can figure out based on the angle measures and what we know about parallel and perpendicular lines. Now, looking at 22, we're using this quilt block here. So it says Lucy is designing a block for a quilt. She measured one of the angles. What is the measure of the unknown angle? So we know that that straight line is 180 degrees. We're taking what we know, 180 degrees, and we're going to subtract the other part that we know to find our unknown. So we say 180 degrees minus 110 degrees equals x. X equals, and when you do your subtraction and double check your work, you should get 70 degrees. (23) A tile has two pairs of parallel sides and two pairs of equal sides. What shape is the tile? So we want to pay close attention to the information that they're giving us here. They're telling us that the tile has two pairs of parallel sides, so it cannot be a trapezoid. And then it has two pairs of equal sides. So it's not saying that all the sides are equal. It's saying that maybe these two sides are equal, and then these two sides are equal. It also does not tell us that we have to have right angles. So it can be two different things. It can be a rectangle, which is what I drew here. Or it could be a parallelogram if the sides, as long as all the sides are, this side and this side are the same, and this side and this side are the same. Okay. 24. A gear watch turns in 1 degree sections. The gear has turned a total of 300 degrees. How many 1 degree turns did the gear make? So if the gear turns 1 degree each time it turns, it only turns 1 degree, and it's turned a total of 300 degrees, it has made 300 1 degree turns. So it sounds really tricky, but it's just asking if it turns 1 degree each time and it's turned 300 degrees total, it has made 300 turns. Now, 25, there's a few different ways to solve this. I'm going to explain to you what makes sense for my brain, but then I encourage you to write your explanation for what makes sense for your brain, because everybody's brain thinks differently. So a Ferris wheel turns 35 degrees before it pauses. It then turns another 85 degrees before stopping again. What is the total measure of the angle that the Ferris wheel turned? How many more times will it need to repeat the pattern to turn 360 degrees? Explain your thinking. So the first thing that you're going to look at is how much has it turned total so far. So it turns this yellow part and stops, and then it turns this red part again and stops. So what's this total angle measure? So we're going to take 35 and 85 and add those together. And you should get 120 degrees. Now for it to make a total turn of 360 degrees, you can do it a few different ways. Like I said, you can multiply 120 by 3, and that gives you 360. You can guess and check. You can multiply 120 by 4 or 5, and then subtract by 120 until you get 360. Or the way that I would think of it is you're going to subtract 360 by, you're going to subtract 120 from 360 until you get 0. So you should come up with that it's going to make 3 total turns or 2 more turns to complete the 360 degree turn. And then you write your own explanation. So to show you what the math that makes sense to me is, I'm going to take 360 and subtract 120 from that. And then you should get 240. And then you take 240 degrees and subtract 120. And then you get 120. And then you take 120 and subtract 120 again, and you should get 0. So I'm going to count how many times I subtracted 120 total, which is 3, meaning that it has 3 turns total to get all the way around to make that 360 degree turn. It would take 2 more times to repeat the pattern, but if you write 2 or 3, as long as you explain which one, either 2 more times or 3 times total, would answer that question. Either way is fine. So make sure that you do the math and the explanation. You do need some words for that. Explain your thinking. This is a big part of our 4th grade learning, explaining in words, explaining our math in words. Make sure that you include the words on your explanation. So if you need help or if you have any questions about our review, please let me know. Next week, we'll be doing a little teeny tiny bit more of review for Unit 8, and then we'll be doing our test and moving on to our whole 4th grade review. So again, make sure that you've double checked your answers, make sure that you're understanding what they're asking us to do, especially before we take our test. Otherwise, I will see you later.